Hey, what's going on? It's Legend today, and today I'm doing a chemistry video because I got some requests from some friends to do it. So I'm going to start over here in oxidation number because that is something people struggle with usually. Oxidation number basically means how much of something has to pair with hydrogen or oxygen. It's hard to explain in words. I'll explain it through these examples. So here's the exceptions right here. Fluorine is right here. That always has a -1. Oxygen always has a -2. Hydrogen always has +1. These two G's are for group 1 and group 2, which are over here on the periodic table. And they can have 1 for group 1 or 2+ for group 2. And halogens is right here. Halogens is group 17. Group 17 is right here. And they always have a -1. So in number 1, O is already seen, so you can already put down 2 negative as the charge, because that's an exception. And if you have 2 negative for oxygen and you have 6 oxygens, that's -12 overall. -12 charge. So you need a 12 plus charge to go with the -12 charge to get to 0, which is a net charge of nothing. And that's what all compounds or molecules want to be in most cases. So sulfur has to be a 12 plus charge to go with -12, since 6 times -2 is -12. So here's the answer to number 1, 12 plus. Number 2 has 3 instead of 2. Hydrogen is an exception, and you have to learn these exceptions if you want to actually know how to do oxidation number. And all it spells is fog, just with a couple extra G's and H's. That's it. And so H is already seen, so that's +1 since it's hydrogen. O is already seen, so it's 2- right here since it is oxygen. It has 2- oxidation number all the time. Carbon is where the question lies, really. And so if you have 2 right here of a +1 charge, that's a +2 charge. If you have 3 oxygens, and oxygen has a 2 negative charge, that's a -6 charge. So -6 plus 2 is -4. You still need 4 to fill in the oxidation number so it has a net charge of 0. And what's left is 4, so that is what carbon is. Carbon has to be 4, because if you have a 2 plus charge right here as a 2, and you have a 6- charge right here, you have to have a 4 charge to get it to 0. And by the way, if it's on a test like this, always put +1. Don't put like +2, even though there's a 2 right here, because that's the exception. They just want you to put the exception down. Moving on to number 3. It's NO2 with a 1- charge. This whole thing right here is referring to all of it. All of it has a -1 charge overall. So if oxygen always has a 2- charge, and there's 2 oxygens, that means that that's a -4 charge. And so you probably picked up that you need a 4 to get this thing to 0. But you're wrong. Because since it's all a -1 charge, that means there has to be 3 nitrogens. Because if you have 3 nitrogens and you have an overall oxygen net charge of -4, -4 plus 3 is -1. Because if you put 4 right there, it would be neutral. And in this particular question, it's not asking to be neutral. It's asking to have a -1 charge. And by the way, this is nitrate, which you probably need to know. Moving on over here, naming ionic compounds and their formulas. So if you have gallium, which is right here, that's a 3+ charge. If you have arsenic, which is right here, that's a 3- charge. The charges are at the top or bottom, by the way. And so you would put gallium as the first part of the answer, since that's how you go. Then you space. And it's arsenic, so you put arsenide because it's an ionic compound. And for ionic compounds, if it ends in a nonmetal, you end the ending with "ide." So it's gallium arsenide. And I'm going to go over number 1 really quick, just as an example. Number 2 is also an example, but I'm not going to go over it. So if you have NH4 right here, that is ammonium. And ammonium is a polyatomic ion. And the first part of the name you never change. So you just put ammonium right here. Simple enough. And since ammonium has a plus charge, plus 1 charge I should say, it needs a negative 1 charge to go with. And that's where chlorine comes in. Chlorine has a negative 1 charge right here, since it's a halogen. And so they go together to form a net charge of 0, and you can assume these always are after neutrality, unless it properly says that they're not. And so that's where chlorine comes in, but you change this ending since it ends in a nonmetal. If it doesn't end in a nonmetal, don't change the ending. But if it does, change the ending to "-ide" all the time. That's just a rule of thumb. This one right here, number 4, is a little different. Pb is right here, which means it's multivalent. It's not a transition metal, but it's multivalent. Meaning that it can have multiple valences in its outermost shell of the electron cloud. That sounds complicated, but it just basically means that it has a different number of valence electrons each time. So in this particular one, you have sulfate right here. Sulfate is on the common polyatomic ions table in the right-hand corner of your screen. And sulfate is SO4, that's right here, but there's 2 of them. And sulfate has a 2- charge. And if you have 2 2- charges, let me do some math right here. 2 times -2 equals -4. That's common algebra right there. If you don't get that, then you're really dumb. So anyway, if you have a -4 charge, you need something with a +4 charge to come in. And so Pb is commonly accepted as lead, so that's the first part of the answer. And now, this is where it gets tricky. You need Roman numerals because it's multivalent. That's the key word. If it's multivalent, you have to use Roman numerals. And you have to use Roman numerals to represent 4 because it's a +4 charge to go with the +-4 charge, or the -4 charge of sulfate. Because there's 2 sulfates, and sulfate typically has a -2 charge. So it's lead with the Roman numeral 4, which is represented by capital IV, and sulfate. Because it is not a nonmetal, you do not change the ending. Okay. And so, aluminum right here. Aluminum has a +3 charge up here, because it's in group 13. Cyanide has a -1 charge, and there's 3 of them, meaning that they go together. 3 cyanides pair with 1 aluminum evenly. So the first part is aluminum. And the second part is just 3 cyanides, and they're polyatomic, so you don't have to change the ending, so it's aluminum cyanide. Moving on to these over here, naming ionic compound formulas. 3 through 5 is what I want y'all to do on y'all's own, and I will go over the answers in a second. Okay. Pause the video if you want to answer them, or don't, because I'm about to go over them right now. So Cobalt 3 oxide, what that means is that cobalt needs to have a 3 charge, and it needs to go with oxygen, and since oxygen is 2- charge, you need 3 oxygens to pair with 2 cobalts evenly, because that is the least common multiple math term. 10-2, that means that you have SN, which is exception to the multivalency rule, meaning it is multivalent, and it has a +2 charge, and it goes with nitrite, I should say. Nitrite is NO2, so it goes like that. And you need 2 nitrites since it has a -1 charge to go with. That's to go with 10, so that's what it looks like. And then do number 5 on your own. I'll leave a link in the description to all the answers.